Good morning from the garage. So today we've got our first EV van repair. The battery box is damaged, so before we do anything, we'll plug in the scan tool, see if there's any additional codes we need to worry about, and then what we'll do is we'll show you what the Powerdown procedure is. It's one of these Maxus Edeliver R9 vans, so let's have a look at it and let's see what's involved. So the customer has said this van had cut out a couple of times, so we see that there's a charge indicator low side control relay R and G saying open circuit, which would explain why the van sometimes wouldn't go. But the concerning one is this battery temperature measurement fault, and also cell temperature different, and it says large. So we need to be careful when stripping this battery when we finally get the battery removed from the vehicle to make sure that there isn't any cells starting to rise in temperature, because what we don't want is thermal runaway with this. This is where the serious issues can begin. Okay, we've ran the scan and we know there's an issue potentially with the battery, with our temperature problem, so we need to be careful with that. You always run the scan before you do the power down to make sure the contactors are going to open circuit when you turn the ignition off. So you can see just now it says ready, so what you want to make sure is that ready light is not there. So I put it in the park, I'm turning the start stop button off. I'm going to take the keys and I'm going to put the keys at least 3 meters away from the vehicle. So here's the keys here. We know the ignition's off. Let's take them, put them in a lockbox out the road, and the next stage is we're going to disconnect the negative terminal of the 12 volt battery. Okay, so I've opened the bonnet. You've got a 12 volt battery here, positive, negative. We've disconnected the negative terminal. I've put a black insulating glove, you can see, over the terminal tie strap. That's just to make sure at no point can that 12 volt cable go back and touch onto the negative terminal of the battery. So remember, on electric vehicles, this is called the low side, i.e. the low voltage side, the high voltage battery, the high side, and the low side is what controls the high voltage circuit. So you need to make sure that's disconnected. That's why you need to make sure the ignition's off before you do anything. So ignition's off, keys are out the road, negative terminal's disconnected. We've covered it to make sure it can't reconnect, and now what we're going to do is we're going to go down to the manual service disconnect, which is on the battery box. Okay, just to run you through some of the tooling we're going to use. So we've got a face mask just to make sure we're protected from any potential arc flash from high voltage system. We've got a class 0 1000 volt insulated gloves, which I'll show you how to test and check in a wee second. We've brought a set of over gloves with us. I don't personally tend to like using them, but the idea of using these gloves here is they've got no insulating properties at all, but you put them over the top of the insulating gloves, so that they basically can't get cut or split when you're using them, so they protect the insulating gloves. Right. Okay, so to check them, open the fingers, make sure there's no damage to the fingertips. What you do is cover the end and roll it up to trap the air in it. Once you trap the air in it, you just hold them like that to make sure that they don't deflate. So that glove's okay. Second glove, again, these are pretty much brand new, so they've only been used once before. They look okay. Let's trap the air in them. Always check them every time you do a power down. So they've got to be tested every single time you do this procedure. Both gloves are alright, we've checked them, we're happy, we can use them. So here is the manual service disconnect on the front of the battery box. So this is the front of the vehicle here, that is the back. So we can see the main plug, anything that's orange is high voltage. So these are your high voltage cables going to the inverter. That's your manual service disconnect. This is a low voltage plug here that controls essentially the circuit. So what we're going to have to do is remove the manual service disconnect. We're going to leave it for, it says in the manual 3 minutes, we're going to leave it for about 5 minutes or so. So here's a manual service disconnect. All of these plugs have a secondary lock on them. They're normally a different colour to the rest of the plug. So in this case it's the green tab here. So we've pulled it out. We've got the gloves on, and essentially what you do is you pull the lever forward. It's tight, right here, and then we just unplug it. Okay, we'll discuss what this plug's got on it in a wee second, but that is the manual service disconnect removed. So just a wee explanation about this MSD that we've removed. So essentially when you take this plug off, what's happening is you're breaking the battery circuit, because remember, these big batteries are multiple small batteries connected in series. So when you remove this, you're breaking the series circuit. And just to prove that, we've got the multimeter on the continuity. There's the two large terminals here. Touch them together. So they are both connected. So essentially you've got one part of the high voltage circuit coming in here, passing through and carrying on to the battery. But removing that, you're breaking that high voltage circuit. Also in the middle, there's a small 2 pins here. That's the low voltage interlock. So it's just what they call an additional safety. But removing that plug, although we've got the ignition off and the battery disconnected, we've also disconnected the low voltage circuit by removing this plug. So that's your low voltage interlock, and that's your high voltage MSD. So when you're doing the NEV work, it's important to use the right level of multimeter. So we've got a Cat 3 1000 volt multimeter. Of course the leads are Cat 3000 volts as well. They normally come with these tips on them. And what the tips do means if you remove that, if you were to hold it at that side, that would only be category 2. As long as your finger is at that side of that rib, they're still Cat 3000 volts. Of course, before we do the check on the battery to make sure there's an absence of voltage, we need to make sure this multimeter is working correctly. So I'm going to use this proving unit from Fluke. Essentially this puts out 240 volts. So we'll check it says 240 there. We'll then check that it says 0 volts on the big battery, and then we'll come back and we'll double check that the multimeter hasn't blown while doing the second test. So I'll put this across it just now. There it says 238 volts. I'll just swap the polarity around, and we've got minus 238. So the multimeter is working. We're going to double check that the high voltage battery, we'll need to put our PPE back on, is at 0 volts, and then we'll come back to the proving unit to make sure that this multimeter is still working. Okay, so there's the manual service disconnect plug there. Where we're checking for absence of voltage is this plug. You can see it's got the main 2 cables coming out of it, which are the positive and negative, from the high voltage circuit up to the inverter. It's got a secondary lock on it, which I've already pushed back, and then what you do is you push a clip in, peel this back. It's quite tight, this plug. What we've also done is removed the 8mm clamp here just to give us a bit of movement, and then we'll pull this back. There we go. And you can see there's the 2 main high voltage terminals, positive and negative, coming out of that battery. So that's where we're going to check for absence of voltage. We can also check on the way back that there's nothing coming back from the inverter and the 2 main terminals there. So here's the 2 main contactors here. You can see actually it says high voltage main circuit plus, high voltage main circuit negative. So what I'm going to do is, we've already checked the multimeter on the proving unit, we know that it works. We're going to check across the 2 terminals, see what we have. And just now we have got 1.5 volts. I'm going to swap the polarity around. 1.5. That's kind of strange, mind you, because it says this is the negative and that's the positive. What is concerning slightly is when I put the black terminal just on the earth of the body and pick up one of the terminals, it's shown that I have got, well, it says there minus 50 volts. I thought we should have had 0 on both. Remember, this battery is damaged, so we don't know if part of the high voltage cable is rubbing against the battery box inside. Nothing there, 50 volts. So I've checked the high voltage battery, we've come back to the proving unit. We want to make sure that our multimeter is working still correctly the way it was the first time. So back on here, and it's still reading 238 volts. So we know the multimeter hasn't blown when we've touched that battery pack. Minus 238. So that's called the live, dead live. So first check is the live, make sure the multimeter's okay. The second check is the dead, make sure the battery's got nothing coming out of it. The third is the live again, make sure your multimeter is still working. So the customers initially complained that there's a damage to the battery box. You can see that there. Good potential there's water ingress in here. There's another piece of damage there. The vehicle was intermittently going and not going, but it does have, as we've shown, the fault code on it, which is saying cell temperature. So we do need to be careful with this. We've got potential cell temperature rising, and we seem to have voltage coming out of the battery after the interlock and the manual service disconnect has been removed.